So as I mentioned earlier, on the Learn page, there's a document up there. Will take a little while to load. There's a document up there that relates to how we should do the electrical component for Project 3, which is the reflected ceiling plan for your designated lighting. I'll just bring up that document. So within Project 3, right down the bottom, there's this one here, which is lighting calculation, or lighting calcs. So open that one up and have that in front of you. So when it comes to determining lighting for a building, it's not a random occurrence. It's calculated and placed appropriately. So you'll see in this room here that you have lighting bays up above us, and then they're all spaced evenly to provide a reasonable amount of light at the desktop. So as you can see just here on the screen, that's a typical, I'll say, reflected ceiling plan for an open office environment. So when that enables lighting throughout, like evenly spread throughout a room. If it was individual offices, of course, then it'd be different. It'd be designed differently for that. Within this reflected ceiling plan, we can see that there's a grid formation happening. So this is actually a fairly large floor plan, or floor plan for quite a large office. Those grids will typically be spaced at 1200 by 600 centres. And then each of these crosses with the circle in there, that's a lighting bay. So you'll want those spaced fairly evenly, and as you can see in this one, they're spaced at approximately every 3 meters, so that you get even light coverage throughout that room. I'm expecting that that's the type of reflected ceiling plan you do for this project as well. It makes it easy to have a grid type ceiling system, because that's something that's easily modified for changing use. You can have your electrical supply with just your 3-pin sockets to your lighting bays, spread about the place in the ceiling up above that acoustic tile setup. And then if you want to concentrate more lights in one area, you can take lighting bays out of one section of that grid and move them over to another and power them like that. So that enables a decent amount of flexibility, but it's also a very simple thing for you to draw up as well. So you can just produce a grid for your floor and then drop your lights in there. When you're producing a reflected ceiling plan, that reflected ceiling plan is the same as your floor plan, but it's as if you're just dropping lights directly on there. Now, if you were to lie on the floor and look at the ceiling plan, it would actually be the opposite of that. But to make our reflected ceiling plan relevant or easily compared to our floor plan, we do it from up above, but as if we were looking at the lights. That makes sense. So it's like there was mirrors all on the floor, and you're looking at that ceiling. So that's the way we produce it. Now, to decide which lights you need to have in there, that's not so much a random occurrence. That's happening through a calculation, and I'll backtrack just a little bit. So when we look at, or when we think about electrical power, our electricity is supplied in watts. So we purchase kilowatt hours. So 1,000 watts used for 1 hour is 1 kilowatt hour. So if you want to have a look at the power consumption of all your electronic items at home and think, how much is this radiant heater going to cost me through winter, you look at how many watts it is, multiply that by how many hours you're going to be using it, that gives you your kilowatt hours. It used to be with the old incandescent light globes that you'd go, oh, I think we need a 100-watt light globe in here, or we need a 40-watt or a 25-watt, etc. Now, because there are many different light globes on sale, it's not just incandescent light globes, the comparison is actually about their light output and not their wattage used. So that's that. So yeah, so the amount of light emitted from a globe is measured in lumens. And an efficient lamp will provide the same amount of lumens with less energy compared to an inefficient lamp. So we want to know about the lumens supplied. So here from this chart you can see a 19-watt LED light. So we have our lumens here on the side of the chart and our wattage as we go across. Our 19-watt LED will produce about the same lumens as a 100-watt incandescent. So our 100-watt incandescent here, so 1600 lumens, our LED can produce the same lumens but from only 19 watts. But as you'd know, the different globe types produce a different type of light as well, which is also a consideration, particularly more for residential applications where you want a certain light. Within office environments, it's primarily about energy saving is the main driver. So to know what globes we need or what type of lights we need within an office environment, there's an Australian standard for working through that. That's AS 1680. It goes into a whole lot in regards to the colour temperature of light, warm or cool. So your warm lights are your incandescents. That's sort of your orange and red of the colour band, and then your cool lights, which are things like LEDs and fluorescent globes. And it also takes into consideration reflection of light within a surface, whether it has reluctance or reflectance, and distance between the light source and where it's going to be used. But the most important thing for us is tasks being performed, because you need different levels of lighting for different tasks that you're doing. If it were if it was a jewellery shop, for example, you need a lot more light. Like if we're working with fine details, etc., we need a lot more light. Whereas if it's a I don't know, just a general factory, for example, we wouldn't need much light in there. So this table is taken from that Australian standard. So interiors rarely visited with visual tasks limited to movement and orientation. So corridors, cable tunnels, indoor storage tanks, walkways, things like that. You only need the lux of 40, and for our routine office tasks, etc., reading, writing, typing, etc., we need 320. Now you notice I used the word lux as opposed to lumens. So that lux is derived from our lumens, but we can't just, for example, have one globe sitting 10 meters above the ground and say, okay, well that globe produces 1600 lumens, that's enough, because we know that globe isn't going to produce the same amount of light when it actually hits the floor 10 meters below. There's light loss in that, and there's also reflection of light that happens around a room, which contributes to the use of that light. So we need to provide, or for this example calculation, it says we have to provide 240 lux at the desktop, But if we go back up to our table, it's 320, just to clarify if there was any confusion there. But let's say we had to provide 240 lux at the desktop, and our 240, that's for school chalkboard and charts, medium woodworking, food preparation counters for transactions. So yeah, let's say we're doing this for school. Need to provide 240 lux. To achieve that, we look at the illumination calculation formula for that, where we have illumination equals lumens per lamp. So let's say we've got our one lamp, we get our lumens per lamp. Multiplied by our coefficient of utilization, so how much of that light can be used, multiplied by our light loss factor, which is divided by area per lamp. To make that simple for you, for those that did algebra a long time ago, including myself, to rearrange that equation to pull out the calculation for lux, we end up having our 240 lux equals our lumens multiplied by 0.6 for our what is that? Our light loss factor, coefficient of utilization for 0.6, our 0.8 for our light loss factor, divided by 250 square meters for the room. So then, to take that further, then our lumens equal 250 square meters multiplied by 240 lux. So in your example, you'll be what 400 square meters, say, is your office area, or let's say that's 320 square meters office area multiplied by 320 lux divided by 0.48. That 0.48 comes about by multiplying our coefficient of utilization by our light loss factor. So those will stay constant between our calculations, because we're dealing with office spaces with that ceiling height of around 3 meters. So we can use those coefficient of utilization and light loss factor and assume those to be the same, because we're dealing with very similar environments. So in this instance, our lumens that we need are 125,000 lumens in that top floor. In yours, it's going to be what is that? Well, that 125 is about 2/3 of the way there. So we'll be looking at around 200,000 lumens, somewhere in that range, around the 200,000 lumens required for that level. So then once you've calculated how many lumens you need for that area, then go off and do a bit of research to find some globes and see, and we'll want to be using lighting bays that fit into our 600 by 600 ceiling grid system. So probably 600 wide by 1200 long lighting bays would be the one. So we're looking at 1200 long fluorescent tubes or LED options as well. LED options last for much longer and require even less light. So have a look at those. Have a look at what lighting bays are available. What are their lumen outputs, and then find a product which you like, and then divide your requirements for lumens by the lumens that are produced by that lamp. Let's say we need 200,000 lumens, and then we find lighting bays that produce 2,000 lumens each. We'll want 100 lighting bays spread out throughout our office area, and then you can drop them in to your ceiling grid. Does that sound, or does anybody have any issues with that process, Admiral? Is that going to be fairly simple to work through?
While working out the area, we will did the isolated stairways and we just consider the
Yes. Yeah. So yeah.
And are we going to consider different lumens for the corridor area?
I think it's I think provide the same lumens in that corridor area. So more so for practicality's sake, because you're going to be dealing with exactly the same globes. So for a maintenance perspective, it's all just the same globes, and also it provides decent lighting in those corridors as well as the office area, and enables some flexibility. So I think include those because it is an incredibly open plan office. Yeah. I think include those areas within your footprint for calculating. Toilets you can exclude. Toilets, the lighting for those can be done separately. If you wish, you can go back up to the table and look for, let's say, staff change rooms, live storage, bulk material, dead storage materials, etc. Or go what stuff. Yeah, it's going to be more in this. So 80 lux required. If you wish to do your toilet lighting, you can calculate it from this as well and specify that on the plan. But the only thing I require you to do is just to reflect the ceiling plan for the office area, showing that illumination. But that's going to be quite. That one is going to be quite simple because it's probably going to be single globe, unless you're having divided stalls, then you have to have a light source in each one of those. But it's probably going to be a single globe for those rooms and something of around 1,000 lumens to do that. So it'll be quite simple. Yeah. So you've specified your lighting on your or you've worked out how many lighting bays you require at what lumens each, and you've dropped them into your reflected ceiling plan there, like that. The next step is then to produce a very simple legend to say that this is, these are the lighting bays, and this is what's in them. So provide your research about what globes you've chosen and what lighting output they are, and then also produce some notes in there showing these are my calculations for working out what lumens of lighting is required within my office. And then here's a lighting example. So in this example, level of light produced is indicated delivered by a light output. So our lumens are there, and then we have our size and our dimension of our lighting bay in there as well. Oh, these ones are in inches. Oh no, here we go, our millimeters. So 1184 by 284. So 1200 by 300 lighting bay. That one. Yeah. So the main thing is going to be going through that formula and changing the numbers. So this 0.48, that's going to stay constant, but your 240 lux is going to be different, and your square meterage is going to be different. And then you do that, create that calculation to work out how many lumens you're required for spreading out throughout that space. And that's all.